Okay, magandang araw ulit sa inyo. Tayo ulit ay nasa ating pong discussion sa ating subject na thermodynamics. Ngayon, papag-aralan naman natin ang patungkol sa isang thermodynamic property na tinatawag na energy. Yan. So, let us talk about energy. So, ngayong umaga, papag-aralan natin, i-define natin ang energy. We will also discuss two kinds of energy. Yan yung potential energy and kinetic energy. And then, papasadahan lang natin konti yung tinatawag na law of conservation of energy. Okay, so simulan na natin. Now, sa physics, ano ba ang tinatawag na energy? When we say energy, it is the ability to do work. Okay? So energy is the ability to do work. Yung energy na tinatawag, this is the property that is transferred to an object in order for it to do work. So transferable ang tinatawag na energy. Now, the unit for energy, the unit of energy is joules, denoted by a capital letter J. Okay? This is in honor to the scientist named James Prescott Jones. Now, there are two kinds of energy that we will discuss this morning. There are so many kinds and there are so many forms of energy, pero dalawa ang papag-aralan natin ngayong umaga. We will talk about number one, potential energy, and number two, we will be talking about kinetic energy. Okay? Now, ano bang tinatawag na potential energy? Kapag sinabing potential energy, this is the energy due to the position of an object. Kaya tinatawag din itong energy in position or energy of position. Okay? Kapag sinabi namang kinetic energy, this is the energy due to the motion of an object. Kaya tinatawag din itong energy of motion. Okay? So yung isa, energy in position, ito yung energy kapag yung object ay hindi kumikilos. So lahat ng object na hindi kumikilos, meron siyang stored energy na tinatawag. Kaya tinawag na potential. Potential kasi pwede itong ma-convert to other forms of energy. Pero kapag sinabing kinetic energy, yung mga object na kumikilos ay meron na siyang energy which is dependent on its movement. Okay? Now, para mas maunawaan natin konti, halimbawa, meron tayong isang object. Okay? On top of a cliff, for example. Let's say this is a boulder. Boulder on top of a cliff. Minsan, kapag tayo nasa baba, for example, ng isang cliff, we would not go under a boulder. Why? Bakit ayaw nating pumunta sa ilalim ng isang boulder? Simply because, kapag mahulog itong boulder na ito, it could cause damage. Bakit kanyang mag-cause ng damage? Kasi meron siyang potential na mahulog at kapag nahulog yan, pwede siyang manakit, mabigat ito. So, dito pa lang sa kanyang position, hindi pa siya kumikilos, meron na siyang tinatawag na stored energy and that's what we call potential energy denoted by P. Okay? So yun yung potential energy. So for example, itong object na ito, meron siyang ah, meron siyang mass, for example, na 2 kilograms, okay? And it is lying on top of a cliff, let's say 10 meters, okay? So the height of the cliff is 10 meters. Yung potential energy na tinatawag is equal to the product of the mass of that object multiplied by acceleration due to gravity times the height. So this is the equation or the formula for potential energy, where M is equal to the mass of that object in terms of kilograms. G is equal to the acceleration due to gravity, which is a value of 9.8 meters per second squared. Okay? And of course, H is equal to the height of an object. Okay? So, ito yung working formula natin kapag tayo nagpa-compute ng potential energy. So, in this example, wherein meron tayong boulder with a mass of 2 kilograms at a height of 10 meters, kung i-compute natin ang potential energy, we just need to multiply the mass na dapat in terms of kilograms and acceleration due to gravity, which is 9.8 meters per second squared. Kung hindi yan naka-meter, i-convert muna sa meter. And then the height is 10 meters. So dapat kapag nagsusolve tayo, there is consistency in the units. Kung meter yung ginamit mo sa isa, meter din sa iba. Hindi po pwede na meter and then inches, hours, and then yung iba seconds. There must be consistency of units. Napag-aralan natin yan sa ating previous discussion on dimensional analysis. Okay, so yung mga units natin or dimensions natin, dapat consistent sila sa isa't isa. Okay? So, ilan ang potential energy ng object na ito which is lying on top of a cliff 10 meters high kung meron siyang mass na 2 kilograms. Okay? So, solution, potential energy is equal to the mass times acceleration due to gravity times the height. So, potential energy is equal to the mass that's 2 kilograms times 9.8 meters per second squared times the height, which is 10 meters. So you will have potential energy equal to, kung mapapansin mo, meron ka ditong kilogram meter second squared. We need to take note that 1 kilogram meter per second squared is actually equal to 1 Newton. Okay? 1 Newton, the unit Newton, is in honor to the scientist named Isaac Newton. Okay? Siya yung nag-propose ng Newton's law. I hope that you have learned that in your high school physics. So, 1 kilogram meter per second squared equal to Newton. So, lahat ito, kilogram meter second squared would be equal to Newton. So, if I were to multiply 2 times 9.8 times 10, so 2 times 9.8 times 10, I would have 196 Newton meter. Kasi may iwan pa isang meter dito. Okay, so check ko lang, 2 times 9.8 equals times 10 is equal to 196. Okay, so this is 196 Newton. And we need also to take note that 1 Newton meter is equal to 1 joule. So pwede rin natin sulat na the potential energy of that object would be 196 joule. So ganyan lang yung pag-compute ng potential energy. Okay? You need to take note that G is constant. That's 9.8 meters per second squared. Sir, pwede bang magbago yung value ng G? Pwedeng magbago yan. Depende sa location. Kung pupunta tayo sa moon, syempre the acceleration due to gravity on the moon would be lower than the acceleration due to gravity on the earth. Pero usually kapag ang examples natin o kinocompute natin ay based dito sa earth, most of the time naman yan, so that's 9.8 meters per second squared. Although some books would round it off to 10 meters per second squared. Okay, so as a class convention, we would be using 9.8 meters per second squared as our acceleration due to gravity. Okay, so ganyan lang yung pag-compute ng potential energy. Potential energy is equal to mass times acceleration due to gravity times the height. There are also some cases na potential energy ang given. Okay, let's say potential energy is given, pero ang hinahanap is the mass. It should not create any problem. It's just a simple manipulation of equation. So kung mass ang unknown, i-divide lang natin ang potential energy with acceleration due to gravity and the eight. It's just an algebraic manipulation. So you will have m equal to the potential energy divided by h. Ganyan lang. So kung h naman ang unknown, same thing. Just a simple manipulation of the equation. So h would be equal to E divided by mg naman. So these are the possible uh, problems na makukuha natin or mag-derive natin using the equation of potential energy. Okay, so I hope you don't have any question with potential energy. Pag mayroon kayong question, paki-comment na lang sa video na ito at sasagutin ko pagkatapos ng video. Okay? Now, let's go to kinetic energy naman. Okay? Sabi natin kanina, kinetic energy is the energy due to the motion, or the kinetic energy is the energy due to the motion of an object. For example, okay, halimbawa, meron tayong dalawang bicycle. Okay? Let's say meron tayong dalawang bicycle, dalawang bicycle. Okay, halimbawa mayroong isang taong nagbabike, dalawa pala. Okay. Etong isa, meron siyang velocity na 10 meter per second. Etong isa, meron siyang velocity na 100 meter per second. Okay? Papipiliin kita. Saan dito sa dalawa gusto mo mabangga? Yung 10 meter per second ang takbo o yung 100 meter per second? Di ba? Pipiliin natin yung mas mabagal. Why? Sapagkat alam natin na kapag mas mabilis yung takbo ng isang object, let's say this bicycle or these objects have the same mass. Okay? Siyempre, mas malakas yung magiging kinetic energy ng object na mas mabilis kaysa sa kinetic energy ng object na mas mabagal. Okay? Why? Kasi moving objects has energy. Merong kinetic energy. Kaya minsan, kapag merong isang object, let's say object A, na mabilis na tumatakbo at nabangga niya ang isang object B na stationary, for example, once these two objects collide, A, B, ang mangyayari, it's either object B will be pushed away from object A because of the impact, or pwede rin na both A and B would be pushed away because of the impact, or pwede rin na object B will be pushed away and object A will become stationary. So yun yung mga pwedeng movements after collision na tinatawag. Etong mga concepts nito, importante din sa maritime education, sa mga subjects natin sa mga professional subjects natin sa maritime. Like for example, on the concept of collision in our professional subject, of course nangyayari sa dagat na may mga vessels na nagkakabanggaan, and we can compute the the amount of collision using this concept. Okay? Kaya nga ang thermodynamics is a prerequisite to some of our professional subjects. Okay? So moving objects has energy. Now, the kinetic energy of an object is equal to one half of its mass multiplied by its velocity, where, of course, kT is the potential, the kinetic energy, I should say, kinetic energy, m is equal to the mass of an object, and v is equal to the velocity. Of course, velocity has a unit of meter per second. Okay? Example. Let's say we have an object, or we have a car, a small car. Okay, let's say we have a small car with a mass of 10 kilograms, small lang, with a velocity of, let's say, 20 meter per second. So, pinapahanap sa atin yung kanyang kinetic energy due to its motion. So, solution, kinetic energy would be equal to 1 half times mv squared. So, kT would be equal to 1 half of the mass, that's 10 kilograms, times 20 meter per second squared. Okay? So the kinetic energy would be equal to 10 times, so it should be 20 meter per second, the quantity. Okay, so 20 squared times 10 divided by 5 equal to 2,000. Kung mapapansin mo, meron kang kilogram, meter squared, second squared. So kung paghiwalayin ko itong meter squared, meron kang meter times meter. Kilogram meter, second squared is the Newton meter. Or meron kang 2,000 Newton meter sana, or that's equal to the kinetic energy, 2,000 joules, which is also same thing as saying 2 kilojoules. Okay? So, ganun lang ang pag-compute ng kinetic energy. Madali lang. No? Yan. So, kung meron kang kinetic energy problem, 1 half mv squared, pwede naman na mass ang unknown. In that case, again, it's a simple manipulation of equation. Cross-multiply mo lang yung 2 at the other side and divide it by the v squared. So you would have m is equal to 2 kT divided by v squared. You are computing for the mass. Kung v naman ang hinahanap, you would have, i-cross-multiply mo yan, so 2ke divided by m, you would have v squared is equal to 2ke over m, or you just need to get the square root of both sides of the equation, so you would have v equal to the square root of 2ke times over m. Okay, so those are the possible problems concerning kinetic energy naman. Okay? I hope you were able to understand it. If you have questions again, you can comment on this video. Okay? Now, for the last discussion natin, i-relate natin itong potential energy to that of the kinetic energy. Okay? Meron tayong tinatawag na law of conservation of energy. The law of conservation Sabi natin kanina, etong object nito, ang top of the let's say 10 meters high, okay? And meron siyang mass, for example, na 5 okay? Sabi natin kanina, due to its position, meron siyang tinatawag na potential energy. And in that case, the potential energy of that object on top of a cliff, while it's not moving, is maximum. Maximum. Okay? Pero halimbawa, merong nagtulak sa object na yan at mahuhulog. Mahuhulog. The moment na itong object na ito mahuhulog, it starts to move. Okay? Kapag nag-move na yan, nahulog na yan, ang mangyayari sa kanyang potential energy bababa. Okay? Tandaan natin, yung object na hindi pa nahuhulog on top of the hill, maximum ang kanyang potential energy, but with regards to its kinetic energy, it's actually zero or minimum. Okay? Minimum, kasi wala naman siyang movement. So, zero ang kanyang kinetic energy while its potential energy is maximum. The moment na nahulog yung object, the potential energy now decreases, but the kinetic energy is increasing kasi nagmo-move na yan. I hope you are understanding it. Now, pag babagsak pa yung object natin, still, the potential energy is decreasing, the kinetic energy continuously increases. Pag mahulog pa yung object natin, nahuhulog siya, potential energy, again, is decreasing, kinetic energy is increasing. Just before the object reaches the ground, okay, the potential energy will become zero or minimum, but the kinetic energy will become maximum. Ito yung tinatawag na law of conservation of energy. The energy was not destroyed. Hindi nawala yung energy. Na-convert lang yung energy from one form, that's the potential energy, to another form, which is the kinetic energy. Okay? That's the law of conservation of kinetic energy. Ibig sabihin, since this is conservation of energy, ang ibig sabihin, if we add all the changes of the potential energy plus the changes of the kinetic energy, it will have or it will give us zero. Okay? So walang pagbabago kasi yung energy na convert lang from one form to another. This is a very simple formula for the law of conservation of energy. Okay? Sige, para mas maunawaan natin uh, ang law of potential energy plus kinetic energy equal to zero or the law of conservation of energy, let us try to have a simple example. Okay, sabi nga ni Isaac Newton, if you have an idea but you cannot put it to numbers, you don't have an idea at all. Okay, so sige nga, itong idea na ito, ilagay natin sa numbers. Now, for us to understand the law of conservation of energy, let us try to have an example. For example, we have here an object with a mass of 5 kilograms, and that object is located at a height of 10 meters. Let us try to solve for its change of potential energy. And when that object, okay, when that object falls from that cliff, okay, we will be looking for its change of kinetic energy, taking into consideration that its initial energy would be equal to zero because it is not moving, and its final velocity would be equal to, let's say, 14 meter per second. Okay? Let us prove that when we add the change of potential energy plus the change of kinetic energy, that is equal to zero, to prove the law of conservation of energy. Okay? To do that, let us try to look for the change of potential energy first. the symbol delta would denote the change. Okay, so the change of potential energy. So when we say change of potential energy, meron kang potential energy final less potential energy initial. Okay, so the change of potential energy would be equal to potential energy final would be mass times acceleration due to gravity. Hindi nagbabago ang mass at acceleration due to gravity, but the height would be final minus mg h initial. Ilalabas ko lang yung mg natin because these are common terms in our equation. So change of potential energy would be equal to mg times hf minus h initial. So the change of potential energy would be, okay, 5 kilograms times 9.8 meters per second squared times 10 minus 0. Okay? So change of potential energy would be 5 times 9.8 times 10 would be 490. 5 times 9.8 times 10 would be 490. Kilogram meter second squared is Newton times, meron kang meter dito, so you would have Newton meter, or the change of potential energy would be equal to 490 joules. Okay? Now, let us try to solve naman, the change of kinetic energy. That would be equal to the kinetic energy final less kinetic energy initial. The change of kinetic energy, therefore, equal to 1 half mv final minus 1 half mv initial. Ilabas ko ulit yung mga common terms. So change of kinetic energy would be equal to 1 half m times v final minus v initial. The change of kinetic energy would be equal to 1 half times 5 kilograms, okay? And then, so this is squared, and of course, this is squared. Wag nating kalimutan ano yung mga numbers at saka letters. Kasi kung mawalan natin yung isang letter, wala na. Okay, so V initial is 0, so magsi-zero out lang naman ito. Okay, so meron tayong V final, and that is 14 meters per second, the quantity squared. So the change of kinetic energy will be, uunahin na lang natin ito, 14 squared. Okay. So 14 squared is equal to 196 times 5 equals 980 divided by 2 equals 490. Okay? Negative. Negative kasi yung object natin is going downward. Okay? So, we would have kilogram meter squared. The unit that we will have in here is kilogram meter squared over second squared. Okay? Or kilogram meter times meter, this is equal to Newton meter pa rin. Diba? So, negative 490 Newton meter, or that is change of kinetic energy is equal to negative 490 joule. The negative sign denotes that that object is moving downward. Okay? Let's take into consideration, alam natin to sa physics, anything that goes to the left is negative, to the right is positive, up is positive, and down is negative. Okay? Remember our quadrants. Yan, so change of potential energy is 490 joules less 490 joules also for the change of kinetic energy. It should be equal to 0. And 0 is really equal to 0. Okay, so that would prove that energy is conserved. I hope that you were able to understand it. If you have questions, comment your questions below this video or message. Okay, thank you very much, and I hope that you learned something today. Have a great day.